Amie Treuer-Kuehn is up next. She's an ecologist with Texas Parks and Wildlife, and she's the first scientist to be awarded Outstanding Women in Texas Government Award for her work on the EMST project soon after she started. So
thanks. Thank you everyone for having me. I just want to talk a little bit today about how Texas Parks and Wildlife documents Texas landscapes with our ecological mapping systems data, and how we engage the public with our team tool. So, quick show of hands, who here has used the ecological mapping systems of Texas data? Oh great, almost everyone. We're going to prove it. I'll be back in 2030 to give this talk. No, really. It was for those of you that don't know, it is a statewide vegetation map. We completed it in 2014. It took us 7 years to complete. Texas is a big state. Our goals then were better spatial and thematic resolution, which we achieved. We had used 30-meter Landsat imagery and resampled it to 10 meters. We had 398 vegetation types across the state. We had better accuracy than any other map at the time, better ecological interpretation. It really was cutting edge and the first of its kind in that we mapped broadleaf evergreen across the state, and also were able to map invasive woody species on prairie soils. I would like to take credit for this entire map, but I cannot. It was a multi-partner, a multi-agency and multi-partner project. Dr. Dave Diamond's group out of MORAP in Missouri spearhead a lot of this methodology and science. And other states were jealous, so he went to Oklahoma, Kansas, Nebraska, and Arkansas and improved on what we did. And now they all have maps similar to what we have. So we could just say we're done, we completed, there's your veg map, right? But as we all know, landscapes change. And the image in the top is from 2007 to 2014. The red is areas of change, land cover change in Travis County. And for those of us that live here, we know most of that is from some sort of natural vegetation to urban, right? And then the bottom is bass drop, both before our wildfire and after. So both man-made and natural changes do occur on the landscape. And for us to stay relevant and for us to have a useful vegetation map, we need to update it, right? So our goal was to do this every 10 years. We're a little behind, but we have started. We, again, contracted with Dr. Dave Diamond, and we completed the Lower Gulf Coast update in 2022. We will have the Upper Gulf done in 2024, and the statewide completed hopefully by 2030. In the interim, we've done some small updates, including the Arroyo Colorado watershed, some National Park Service updates, and we have sampled all the major grassland ecoregions with an additional 13,000 field data points from 2014 up until now. So the general process from the 2014 map to now is pretty much the same, but we have some new data, which is great. So we now have our mapping with Sentinel-2 satellite imagery data, and that's at 10-meter resolution. So if you notice from the first slide, we were at 30 meters. And that's how we get our general land cover, so that cold deciduous forest, evergreen forest map. That's the first start of this. And we're still using soils data and geophysical setting data like slope and landscape position, and assigning that to what we call image objects to get an ecological system, right? To get the systems that species can use and that we can use for modeling habitat and landscape level planning. But we also have some new tools, including vegetation height from statewide LiDAR, and some other modeling we're doing in-house, including mapping canyons and grassland quality, as well as using some national tools to mask things like urban and cropland data. So this is where we start in our updates. We take about 3 dates of that 10-meter Sentinel imagery. We send our field botanist out with a list of mapping targets built off of Nature Serves Ecological Systems to create a 12 to 16 land cover class map. So the field data. In 2014, we collected 12,000 field data points. We now have an additional 13,000 field data points, and these are all available to the public. A lot of this is collected roadside, some of it on private and public lands. But we are documenting more species than we did the first map. The first map we collected information on the top 3 dominant trees, shrubs, and herbs. We're now collecting information on the top 5. So we're getting a little bit better ecological interpretation this go round. And we are also collecting information on land management and woody species control as we travel across the state. So our field botanist is currently out in the Post Oak Savanna Blackland Prairie ecoregion, one step ahead of our mappers and modelers. So this is where most people stop, this general 12 to 16 land cover class. It's useful, but we can do better. So what we do is we create those image objects, which are just groups of like pixels based off that satellite imagery. We assign all those attributes, soil data, geophysical setting, landscape position, elevation, vegetation height, and then our canyons and grassland quality mapping, as well as those masking tools, all to those image objects to get from evergreen shrub to what we're all here for the last 2 days for, Edwards Plateau, Ashes, Juniper, Live Oak shrubland, right? So kind of warbler habitat or vireo habitat. A little more detail on how this works. Within the central Edwards Plateau limestone evergreen shrub land cover, in Travis County alone, that one land cover is mapped at 5 or 6 different types. On flats and gently rolling hills, on typic soils, it's that Edwards Plateau Ashes Juniper shrubland. On grassland soils, where it's not supposed to be, it's a native invasive juniper shrubland. So this is where we manage for prairies or savannas, right? And then on slopes, it's oak slope shrubland. The new class we have would be a canyon shrubland, and then floodplain and riparian types. And all of these different types, the Ashes juniper occurs with different co-dominant species, and it is different habitat for different wildlife. So where are we at? We started with 398 from 2014. Just on the upper Gulf Coast, we're now up to 411 different vegetation classes. We expect that to increase as we move across the state. We have a new grassland quality mapping where we're able to model 3 new grassland classes, included native prairies, monoculture, hayfields, and then that sort of in-between stuff that's a mix of native and exotic grasses. We have better accuracy in shrub versus forest due to the LiDAR. We have a map of canyons for the Balcones escarpment that we plan to continue that method across the state. And we're modeling music canyons for big-tooth maples. And we're going to use some of the U.S. Forest Service data to hopefully increase our accuracy in pine plantation mapping in East Texas. How do we get all this information out to you all, right? The web is obviously our main source of delivery. This is the parent description for the Edwards Plateau shrubland, which is available both interactive online and downloadable as a PDF. And you can drill down into that mapping system, so the Ashes, Junipers, Live Oak shrubland, and it gives you a description and tells you what codominants occur with that, a photo of the type, and of course a distribution map. It'll also list public lands where you can go see this habitat type. And now how do you download this very large data set, right? It's a statewide data set. Well, you can download it if you have a GIS tool, either by vector or raster, and it's downloadable by ecoregion or statewide. But most folks do not have that. So we did create a Google Maps tool called Team, and I don't know if any of you have used it. And we also have a mobile app called Team Go. Both of them have a citizen science input tool now, so it allows the public to provide feedback to us on where we've really screwed up our mapping efforts. It does say under construction. We have a contract worker who is rebuilding our website, so some of the functionality may not be there. If you go to, I'll have the links at the end, and I apologize for that, but we're expecting that to be corrected in the next couple months. So what that looks like, it's a desktop tool in Google Maps, so it looks just like Google Maps. It's got the ecological mapping systems data in there, and that's going to zoom into an area in Kerr County. And it allows you to view the mapping system's data, which is what just came up, in relation to other abiotic layers like the NHD, National Hydrology Data Set, the soils data set, which is showing now on the screen. And it also allows you to view public land. So if you're going to a park, you can see what habitat types occur within that park. That's the Kerr Wildlife Management Area, the green box on the left. The real cool thing about this is you can upload your study area or your eBird points, buffer them. It will tell you what habitat types occur within your study area, how many acres of each type, give you the description. That's the interactive tool, so it'll link back to those descriptions we have online and the distribution. And then you can also download it as a PDF. So you could take it with you, give it to a landowner if you're working with landowners. So really cool tool. I'm sorry it's still under construction. It should be up and working in the next couple of months. Gives you pie charts of the different types that occur within your study area. Links to the endangered species county level map. And we've created, like I said, a citizen science feedback tool, kind of like iNaturalist, but for plant communities. And it lets you go in, and if you're standing on your property and we say we mapped a prairie full of mesquite, and it's actually tallgrass prairie, you can tell us we did something wrong. So it requires that you go in, select the polygon. It lets you document, tells you what habitat type it is, gives you the description, tells you what dominant species. And you can say, you're wrong, put a point there, take a photograph. It does require a photograph, and then submit it to us. And while we're not going to go in and hand flip each individual polygon, it will let us identify systemic errors in the map. This is our mobile app, and it's just a scaled down version of the desktop. So you can go in, and if you're going for a hike at Devil's River State Park, you can take your little mobile app with you. It will follow you as you walk, real-time location, and it will let you know which plant community you're standing in and what the dominant species are. So a really handy educational tool in order to explore the plant communities of Texas. Obviously, this is best for use in the field, but it also has that ground truth or citizen science data input tool added to that as well. And with that, I can take any questions you may have. Thank you all for having me. Yes. The field data, right? So we use.
You're not determining the species specifically from a height perspective.
No, that's land cover, and then the field data drives our plant community descriptions. So. Mm-hmm.
How about like the soil disturbances, like disturbed areas, doing that from overhead as well?
That's from the imagery, right? And we can't, it's a snapshot, we can't capture every land management decision, especially in grasslands, which change very quickly. You can burn them, and all of a sudden they're not there, or graze them, and it could be a tall grass prairie, and even in the field we can't tell. But yeah, we try to capture as much as we can. Yes?
Are you able to use this offline, or is this
You can use it offline. The mobile app you can use offline, the desktop you cannot, because it's connecting to other data servers. Yes? Yeah, sorry.
Are you guys looking at different crop types, or like are you able to use it all, or just
We are using the USDA's cropland data layer. That's our masking tool, and we're using 5 years of that to determine whether it's row crop, rice agriculture, but just for those types. Yes? Oh, you just go to the website. Let me go back, let me see. It's not really, I don't think this one's downloadable yet. That's in the works, but so you might also need Wi-Fi for this still. The goal is to get it where you don't. But yeah, this Team Go website, if you take a picture of that, you can link to it. I don't think, if it's on a historic prairie soil, it shouldn't be that, right? But it should be, we're gonna map it as native prairie. I don't think we're gonna capture the small mottes. Generally speaking, I don't think we'll get that in the imagery. Yeah, and I don't think we're actually picking those up in a prairie matrix, right? And if we do, it should be mapped as not prairie soil, right? It should be mapped as Ashe juniper soil, right? A typical soil type. Right, and I don't think we're mapping at a high enough resolution to pick up in tiny mottes. Right, yes.
Okay, that's a good place to go. Are we done? Do we have more time? Yeah, okay. We should probably move on then. Thank you. Hey, good job.